we take it. Now, one convention, let's take up as positive. You can take any, let's take up as positive. Just a second, give me a second.
Okay.
Okay, so height is 25 meters. So we are taking downwards as negative. Okay, initial velocity is 20 meter per second. So if the ball is going upwards, we have taken up as positive. So this will be positive. Acceleration due to gravity, this is 10 meter per second square. So downwards will be negative. Now see displacement, this is 25 meters. So displacement is also occurring downwards. So this will be negative. Now we'll use our equation S is equal to ut plus half at square. So minus 25 is equal to 20 into t plus half into minus 10 into t square. So this becomes minus 5 is equal to 4t minus t square. So this equation we get t square minus 4t minus 5 is equal to 0. Now using splitting the middle term, we can solve this.
Yes, ma'am.
T square minus 5t plus t minus 5 is equal to 0. So we take t common, t minus 5 plus 1. Then we take again from here t minus 5 is common. So t plus 1, t minus 5 is left. If we consider this from t plus 1, this becomes minus 1 seconds. And if we take this, this becomes plus 5 seconds. So obviously time cannot be negative. So our final answer is 5 seconds. Means it will take 5 seconds for it to turn.
Okay.
Note down this question, Mariam.
Yes, ma'am, I know I wrote the question. Can you show me? Can you scroll down a bit? A bit more. Done, ma'am. Done, ma'am.
Okay, okay, Mariam. Mariam, I think some students they are joining at 2. Let's just wait for 10 minutes. Okay.
Okay. Okay.
If they'll join, then it's fine. Otherwise, we'll just clear our doubt. Because I think I had mentioned 2 p.m.
Ma'am, over there it was written 1:30.
1:30. No, in the class. In the class, I think I had mentioned 2 p.m. But I
Yeah,
thought
yeah,
I
yeah.
had
The
mentioned
class.
1:30. So that's why I announced them to give the reminder as 1:30. So I think that's why, because some students they are having issues. So let me just wait for 10 minutes.
Okay, ma'am. Okay.
Okay, if the others, otherwise, if you have specific doubts that I can help with you,
No, ma'am, I don't have to.
okay, just wait for 10 minutes. I'll let you know. Otherwise, we'll postpone the class then. Abdul, we have just done this question. Please note this down. This question 2. This is from motion under gravity, similar question to what we did in the last class. Okay, class, note down this question. Then I'll discuss this with you. It says that, Abdul, you have written the previous question. Yes, Abdul. See, this question says a food packet is released from the helicopter, which is rising steadily at 2 meters per second. After 2 seconds, what is the velocity of the packet? Take G as 10 meters per second square. Again, based upon motion under gravity itself, note it down, then I'll discuss. Yes, did you try the question? See, when it says no, food packet is released from helicopter, which is rising steadily at 2 meters per second. It means this is the helicopter. This helicopter is itself going upwards with 2 meters per second velocity. Now, if a food packet is released, what do you think should be the velocity of the food packet, according to you? If it is released from the same helicopter, according to you, what should be the velocity? Mariam, any answer? Helicopter is moving at 2 meters per second. Okay, just imagine a helicopter is there which is moving at 2 meters per second upwards. A food packet is thrown. So initial velocity of the food packet, when it has just begun to be thrown out, what should be the velocity?
2 meters.
2 meters per second. Very good, man. It would be 2 meters per second. Not 0, Abdul. See, it is not at rest. Why? Because it is in the helicopter, right? And helicopter is moving. So the packet is also moving. Whenever, if you are sitting in a bus and, suppose the bus stops, or let's take this example. You want to come out of the bus and the bus is slightly moving. When you jump to the ground, you tend to move a little, you run a little. You don't just stand statically on the ground. You run a little. Why? Because you have acquired the velocity that was acquired by the bus with which the bus was moving. So your initial velocity, that moment, is the velocity of the bus. Similarly, when the food packet is thrown from the helicopter, its initial velocity right now is 2 meters per second. After t is equal to 2 seconds, what is the velocity? This we will find out. So see, time is given. Initial velocity 2 meters per second is given. Acceleration due to gravity. See, it has said that take G as 10 meters per second square. So now we'll take G as 10 meters per second square. What is missing? V is missing. So V is equal to U plus 80. U is to acceleration due to gravity. Again, see, we have to have two sign conventions. See, initial velocity is upwards. It is acting upwards. No, food packet is thrown like this, first upwards, then downwards. So initial velocity, this is acting upwards, and acceleration due to gravity is downwards. So let's take this as positive, this as down, as negative. You can take any direction. So 2 minus G is 10 and time is also 2 seconds. So this becomes minus 18 meter per second. Now, what does this mean? This means magnitude is 18 meter per second and the direction is negative. Negative was for downward. So the direction is downwards. This is how we have to solve this question. Okay, one more point, class. In the last class, I have told you time of ascent means when the particle moves upwards, right? This is time of ascent. And when the particle reaches the highest point, velocity at the highest point becomes 0, and then the particle comes down. This is time of ascent. This is time of descent. So time of ascent is equal to time of descent. This is the case when no dissipative forces are present in nature. If you have dissipative forces present like air friction, you have viscous force, all the dissipative forces in nature, then time of descent increases. Means when you are throwing a ball up, it will reach quickly in the air. But when it is coming down, it will take a lot of time as expected. Okay, so this just mentioned this point also. This I'll tell you, but first note down this solution. Okay, class, this is the last question from motion under gravity. Note it down, then I'll discuss this. Okay, class, let us discuss them. See, two balls are thrown simultaneously. A is thrown vertically upwards with 20 meters per second. See, this is it's like this is, suppose, let's say a tower or something is there. This is a ball. This is thrown upwards with initial velocity 20 meters per second. This is what is written in the first line. Two balls are thrown simultaneously. A is thrown vertically upwards with a speed of 20 meters per second from the ground. And B is vertically downwards from a height of 40 meters with the same speed. So A is thrown upwards with 20 meters per second. This B is thrown downwards with initial velocity same 20 meters per second. And what is the height of the tower? It is given from a height of 40 meters. This is saying from a height of 40 meters. So 20 meters speed of A, same speed, that is 20 meters of B, vertically upwards, vertically downwards from a height of 40 meters. So this entire separation, this is 40. And along the same line of motion. At what points do the ball collide? At what point do the balls collide? See, here no, we have to mark a point by ourselves. Let's imagine, let's take a point. Let's take a point here. I am taking this point as X. So if entire is 40, just the separation from A is X, how much is left? This becomes 40 minus X. So at this point, this is the point of collision, which I am referring to. Now see, time is same. Why time is same? Because if time is same, then only the two balls will collide. If the times are different, one will be ahead of the another one. So time, we are assuming that time is same, 40 minus X. Okay, see, I'll write down this point. When both the balls are projected simultaneously. When both the balls are projected simultaneously, then the time taken by balls to collide with each other is same. Because when the time will be same, then only both of them will collide. If this is moving at a faster rate, it will take lesser time. So both the speeds are also same, time is also same. Just the distance covered is different. Distance covered is different. Let us again assume a sign convention. Let's take upwards as positive. Let's take downwards as negative. You can take any sign convention according to the question, whichever sign convention you prefer. Now let's talk about both the balls. They are different path. How will we calculate? Let's talk about the ball A. That is the first one. It is having initial velocity 2 meters per second. This is thrown upwards. So this will be positive. Acceleration will always remain acceleration due to gravity. And acceleration due to gravity acts downwards. So this is negative. Displacement covered by the first ball is X. And displacement is covered in the upwards direction. Look, displacement is covered in the upwards direction. So this X will be positive. And what else? Time we have assumed it to be T. So if you use the equation, S is equal to UT plus half AT square. This is S1, U1, A1. So this becomes X equal to 20T minus half 9.8 T square. right? This is what we have obtained. Or we can do, let's take this, though in the question this is given, but it will take a lot of time if we discuss it like this here. Let me take it as 10, but in the exam use 9.8, because in the question also it has said take 9.8 just for the calculation here. Otherwise it will take a lot of time if we take this as 9.8. 22t minus 5t square. This is one equation which you have obtained, one equation from ball 1. Coming to ball B, the second ball. Initial velocity of this is also 20 meter per second. But since the ball is coming downward, so its initial velocity will be negative. See, this ball is coming downwards. Initial velocity is downwards. Displacement is also downwards. Acceleration due to gravity is also downwards. So acceleration A2, this will be G minus 9.8 meter per second square. This will remain the same, but displacement for t minus x, this will be negative because displacement is in the negative direction, and t2 is t. Now again you will use the equation s is equal to ut plus half at square. This is 2, this is 2, this is 2. What is s2? Minus 40 minus x is equal to minus 20t minus 5t square. Let's open up this negative sign. So this becomes minus 40. So x minus 40 is equal to minus 20t minus 5t square. This is the second equation. So we have two equations. Let's solve these two equations to find out the variable. Yeah, right? We have two equations and two variables. X is one variable and t is one variable. So x is equal to 20t minus 5t square from equation 1. And this is minus 40 plus x is equal to minus 20t minus 5t square. Fine, let's subtract them. So this becomes positive, this becomes negative, this becomes positive, this becomes positive. Sign changes, this gets cancelled. Minus 5t square plus 5t square, this gets cancelled. So this becomes 40 is equal to, from here we have 40t. So t is equal to 1 seconds. Now we know t. Put it in this equation. X is equal to 20 into 1 minus 5 into 1 square. That is x is equal to 15 meter. Now see, the exact answer, this is coming 15 meter, but exact answer no would be something 15.1 something. Why? Because I have assumed in the question 9.8. Instead of 9.8, I have assumed it to be 10 meter per second square. So, but in your exam, if it is, see, in the question, it was specially mentioned 9.8. So we cannot take it. It's just that in our class, the calculations will be very lengthy and we'll not be able to reach the final answer. That's why I just rounded it off and took it as 10. So answer will not be 15 exactly. It would be 15.1, 15.2, something like this. So be careful with this. Otherwise, when we round off approximately, your answer will come out to be this only. So this is something around 15.1 meters. Note down this question. Question you people have written. Note down the solution. All right, class. So that completes with motion under gravity. So see, these questions are endless. All the questions are of same type. See, we didn't do a different step over here. All the questions which we have discussed, what did we do? Upwards as positive, downwards as negative. We just made a rough figure. And according to the equations of motions which we have studied, we have substituted the values along with their respective signs, right? So this will be valid for all the types of questions that are valid for motion under gravity. Like this question we did, like this question we did, all the questions are based upon the same type of pattern. So just practice these questions because these questions are endless. They are just based upon the same type of pattern. Yes, similar type of questions will come in exam. These types of questions, the type of questions that we discuss in the class, no, these are the common type of questions which repeatedly come in exam. This balls question one, the last question which we did, and that helicopter one, these two are very common. In most of the textbooks, they are present, especially this question. This question is also very important. All these questions come in your, these types of questions come in your 5 markers also. It's very important. Okay, before relative velocity, I just wanted to discuss few graphs with you. Yes, same question was there in last class assignment. Okay. Yes, in the last class assignment also it would be, because it couldn't be, I actually gave it because I thought I would be able to complete it, but I couldn't complete it. So okay, it's good that we have discussed it today. So assignment question also gets on. Just basics of graph I want to discuss with all of you, because you have graphs also in your exam from this topic. See, basics of graphs you should be able to understand. If this is x and y slope, both slopes are given, x-axis is given and y-axis is given, and you're seeing a straight line. If you see two quantities are getting divided, like distance getting divided by time, velocity getting divided by time, any two things that are getting divided by time. So the third quantity, like if distance is getting divided by time, so third quantity is velocity. So this third quantity, this is given by the slope of the graph. And the slope of the graph is calculated using tan theta. For example, if you have velocity is equal to displacement upon time, and you have displacement versus time graph. So how will you calculate? So tan theta will be velocity from this graph. This is how we calculate graphs. Graphs are basically pictorial representation of a function. This graph is known as a straight line graph. Straight line graph means y is directly proportional to x with the power 1. Now from this you have different types of graph. Positive slope graph. See, if this angle is acute, like this, acute angle means the theta is less than 90 degree. 30 degree, 40 degree, 45 degree, 60 degrees, all these values are the angle of angle which is being subtended by the third quantity. So here, whenever you have theta acute, that is less than 90 degree, tan theta becomes positive, tan 30 degree, tan 25 degree, all these are positive. So if tan theta is positive and slope is equal to tan theta, and we know that slope is equal to tan theta. So if tan theta is positive, slope also becomes positive. This type of graph is a straight line, but the type of slope that we are obtaining is called a positive slope. Then secondly, if you have theta as obtuse angle means it is greater than 90 degree and lesser than 180 degree. This is obtuse angle. So tan theta for that will be negative and slope will be negative. Like, see, this is also a straight line graph, but angle is greater. This was for acute, this is for obtuse. So the slope is negative, the graph is a straight line. Graph is still a straight line graph. Okay. Last is zero slope. Zero slope means when the value of slope is 0. So see, there is no incline. See, this is also known as a straight line graph. All these are types of straight line. This is also a straight line graph. But here, the angle, see, if you, how do we take the angle? Theta is actually angle with respect to the x-axis. This is with respect to x-axis. So if theta is with respect to x-axis, this is just parallel. This is 0 degree. So slope will be 0 and tan theta will also be 0. Because tan theta is 0, that's why we are getting the slope as 0. So these types of slope we refer to as zero slope. So zero slope, positive slope, negative slope, these will be used in certain questions. Note down this. One or two things I want to discuss apart from this. Note it down first. Yes, Abdul, you have to draw this as well. And this is not a diagram, this is a graph. Graphs are important. We are discussing graphs only. So draw them as well. Okay, Abdul, no worries. Let me then delete the after class assessment routine. Okay, in the next class, I'll then cancel the after class assessment routine. Don't worry. Regarding the types of slope, you have see that otherwise we have discussed what type of slopes we have. Linear slope, straight slope, positive, negative. But regarding constant and variable, we haven't discussed. So how to identify whether one slope is a constant slope or this is a variable slope? Best method is, see, you know this angle is theta. Take one point. Let's say this point is B. Make a line parallel to x-axis. Now make theta again. Now take one more point. Again make a line parallel to x-axis. Take theta again. Do you notice theta A, theta B, theta C, all the values of these theta, they are same. Theta A is equal to theta B is equal to theta C. If theta is same, it means all the tan theta will be constant. That means slope of A is equal to slope of B, which is equal to slope of C. Why? Because all the angles are different. So the best way how to identify, so it's a constant slope. So what you can conclude that this is a constant slope because the values of angles are not changing. And if angles are not changing, tan theta won't change. If tan theta won't slip, the slope will be the same in all. Now regarding a variable slope, look here, this is an increasing slope. How to identify that this is an increasing slope? Again, let's say this point is theta A. Now take B point, make an axis parallel to x-axis, take theta B. Again, this is C point. Make this angle as theta C. Can you see angle A is so small, angle B is greater, and angle C is the greatest? Can you see slowly increasing, increased? So this is increasing slope. Theta C is very greater than theta B, then theta. It means slope of C is greater than slope of B, which is greater than slope of A. And similar condition in decreasing. Theta A is the greatest here. Theta B is decreasing. Theta C here is decreasing further. So here the graph is, here you can see angle is decreasing. So tan theta is decreasing. So slope is decreasing. Here MA was the least. Here MA is the highest. So this is how, by looking at the exponential graphs, you have to identify whether it's constant. Regarding these linear equations, quadratic equations, we'll do later on. Quickly just note down these parts. Okay, I've cancelled your after class assessment today. Have you all completed till here? Just text me once you are done. I'll stop here then.